Okay, this is going to be the review 2017 for the rationals unit. There's some new techniques, some new problems. Because of my pen malfunction, I'm going to do a lot of it from the computer. So just try to follow along. No, it's not going to be like my traditional videos. All right. So the first problem. All right. What you're going to do is you're going to put. You got to factor this part first. So what I'm going to do is I'm going to go to equa, menu and equa, and I'm going to type in 1, -3, and -10. And so what that factors to is x minus 5 and x plus 2. All right, so I got x minus 5 and x plus 2. Okay? Let me change the width of this pen real quick. All right, so x plus 2. All right, so I got x minus 5 over top. Now, what you want to do is sort of do this as you go, and I'm going to cross that off. Now, whatever you cross off, the solution for that is the whole. So that's x equals 5. Okay, I can't graph that yet, all right, but I can start with that. Now, what I'm going to do, the vertical asymptote, okay, the vertical asymptote is the solution of this factor, okay? So that's going to be x equals -2, all right? So I can graph that. So I go to here, and I just put a dashed line going straight down the grid. All right? Now, that's the vertical asymptote. All right? To find the horizontal asymptote, what I do is I go y equals, and I divide the number in front of x in the numerator, all right, and the number in front of x in the denominator, I'm going to divide them. Okay? So now in this case, I don't have an x in the numerator, so I'm going to have a 0. The number in front of x in the denominator is 1, so 0 divided by 1 is y equals 0. So now I've filled in all the information, all right? And I make the little asymptote going across. Now, what I want to do to make the graph is I'm going to go into the table, all right? So what I'm going to do is I'm going to type in what I got left over, and I'm going to do parentheses around the 1 and parentheses around the x plus 2. All right, table. Now, I'm going to focus in around these points. So I'm going to do -1, puts me at 1, so I'm going to plot that point. 0 is going to be 0.5, right there. And then 1. I'm just going to do about 3 points each way, 0.3. That way I can see where I'm at. All right, and so what's going to happen is it's going to approach the asymptotes, both the horizontal and the vertical. Now I'm going to go the other way. I'm going to go -3, which puts me at -1. Okay. I'm going to go -4, which puts me at -0.5, which will be right here. And then -5 is going to be at -0.3. All right. So that's what my graph looks like. Okay. Moving over to number 2. What I want to do is I want to get this to be a common denominator first. So what I'm going to do is I'm going to multiply x minus 4 by the top and the bottom. Okay? So what that turns into is -1, and I distribute that 2. All right? So that's going to be positive 2x minus 8 over the common denominator. Okay? So that's going to be 2x minus 9 over x minus 4. Okay? There is no whole here because I didn't eliminate anything. So that's going to be none. Okay? The solution of that denominator is x equals 4. So 1, 2, 3, 4. Vertical asymptote for that. The horizontal one, the number in front of x in the top is 2. And the bottom is 1, so it's going to be y equals 2. All right, so that would be here. Okay? So once again, what I want to do is I'm going to graph this right there. Okay? All right, I'm going to graph that right there. So I'm going to go into the table. All right? And I'm going to put parentheses around 2x minus 9. And parentheses around x minus 4. All right, and now so I'm going to work around, first I'm going to go 5, which is 1, okay? Then 6, which is 1.5, and then 7. So I go a couple each way, 1.6. So what that's going to do is it's going to go like this, and it's going to go down. All right, I'm going to go the other way. I'm going to do 3. It's going to be 3. It's going to be 2. It's going to be 1. All right, so there we go. All right, now for this one, which one is the parent? So what you want to do is you want to go into menu and graph, all right, and you want to graph these, all right, and you want to see which one looks similar. All right, so when I graph that one, all right, I draw it, it looks nothing like what I got, so that's not it. Then I'm going to go the next one, which is x squared plus 3x plus 1 over x plus 1. I'm just saving some time by not deleting it. Okay, I'm going to draw it. Okay, looks pretty similar, but not quite. All right, the next one's going to be x minus 1 squared divided by x. Draw. That looks pretty similar, so I know I can circle that one. All right. And then I'm going to come to this one, which is x plus 1 divided by x squared plus 3x plus 1. All right? So all I'm drawing is comparing what they are. And that doesn't look anything like it, so that's the only one. All right? Number 4. Oh, whoops. Hold on one second. For whatever reason, I don't know where those problems went. Hold on one second. Oh, I only printed page 1. So it'll take 1 second. All right. So a couple things. Let's go back while we're waiting for that to load. All right. The number one thing you want to do is, as you work, the first thing you're going to find is the whole. I'm sorry, I forgot something on here. All right, that I want to go back and touch on. At x equals 5, 1, 2, 3, 4, and 5, you got to go ahead and put a whole on 5. I apologize, I forgot about that. Sometimes people forget about that. So I got to make sure that I put a hole right there on the graph. All right. So let's go on to this page. Okay. All right. It says which of the following is a possible graph of a rational function with the domain can't be x equals -2 or 3. Okay. So what you're looking for there, and the range is y can't be 0. All right. Okay. So what you're looking for are all the graphs that either have holes, okay? You're looking for stuff that have holes there or asymptotes there. All right? So in this one, okay, this has a hole, it looks like at -2, and at 3 here, all right, and it's approaching this. So this would be considered one of those, okay? This one, all right, is not going to be that because this circle part doesn't approach. Okay, this isn't going to be at because it'll be okay at 3 and it'll be okay at 0, but it doesn't have a hole there. This one goes all the way through, so it can't be that. This one is going to be 1 because at that hole, all right, it has all these 3. Okay, so we're going to go ahead and circle those 2. All right, let's move on to that. All right, so hopefully you're able to see that. All right, so that's what you're looking for. All right, which of the following shows the transformation of this? What I would do is just go ahead and graph that. All right, and see which one lines up. All right, -1 divided by x minus 3. Whoops. 3 squared. Okay. Draw. Okay, and so what I'm looking for is that one that's going down like that, and so this one right here would be my answer. Okay. Let's go to the next page, page 6. Okay, all right, so now we're going to get into some characteristics here. All right, So what you're going to want to do here, just like the other ones, is you're going to want to factor it. I want to make sure you can see that. Yep, we're good. All right, you're going to want to factor, all right, and answer these questions as you go. So I'm going to go to menu, and I'm going to go to equa. Polynomial degree 2, that's 2, that's -7, that's -15. All right, so that's going to be x minus 5 and 2x plus 3. All right, the bottom one, I'm going to factor 1, 0, -25, x minus 5, x plus 5. All right, so those cancel each other out. So I got a whole at x equals 5 again. Okay, what I got left over, all right, is x plus 5 on the denominator. So my asymptote for that would be x equals -5. And then to figure out the horizontal, that's y equals 2. All right, now, before I get to these other two, all right, these answers are always going to be, all the time, are going to be your horizontal asymptote number. All right? So that's going to be 2 and 2. Okay, to find those other things, what I'm going to do is I'm going to go into graph. So menu and graph. Anytime they ask for the intercepts, I'm going to put 2x plus 3 divided by x plus 5. Draw. All right, now to find the x-intercept, g-solve root. All right, that's x equals -1.5. All right, g-solve and y-intercept is 0.6. Y equals 0.6. You can write that as a coordinate point as well. So to answer these questions, it's got one y-intercept, one x-intercept. All right, going on to question 7. This is to test your knowledge of when it says this, okay? When it says that, that means that's going to be your horizontal asymptote. All right, so if you read this information, the horizontal asymptote is y equals -8. So that's just like that. All right, okay. Question number 8. All right, question number 8. What you're going to do, all right, is you're going to go to menu and graph for that. Okay, because these won't. Just to save us some time, those won't eliminate. All right, so what you're going to do is you're going to put in parentheses x squared. All right, minus 9. Whoops. With a divided by x squared minus 25. Draw. All right, when you got these like this, you're going to do g-solve max, okay, which is 0.36. Okay, and then g-solve minimum, okay, which there wasn't any. All right, so what would end up happening is it's going to be y is greater than 0. And y is greater than 0.6. See your teacher, all right, for more clarification on that. All right. Going on to number 9, state the domain. All right. So what I was going to do is, because these are all alike, I can cross those off. All right. So that means I have a whole at x equals -3/2. Now what's left over is this in the denominator. So my vertical asymptote is x equals 1. So my domain will be all real numbers, except x can't equal -3/2, and x can't equal 1. Okay? So whatever those are in, you got to put those. Those are called the exceptions. All right? Going on to 10. All right? Now, here's where you actually have to draw the asymptotes in there. All right? So what I'm going to do, all right, that's going to be at like y equals -2. All right? I'm going to draw that in there. All right? This one is going to be at, vertical is going to be x at -3. All right? So we know because of this that this answer is -2, -2. All right? Okay? For domain, domain will be all real numbers except x can't equal -3. Now, for the range, if you notice, there's a curve below the asymptote and a curve above the asymptote. So that's going to be all real numbers except y can't equal negative 2. We'll get to another example where there's an inequality. Increasing, decreasing. All right, this is decreasing from negative infinity to negative 3. If you notice, that comes from this. And then it's also decreasing from negative 3 to infinity. So it's two decreases. All right. Once again, see your teacher. If you trace it, that's decreasing. You start from here. See your teacher for more information. What could write two different equations that could represent this? All right. So the idea is, if I have a vertical asymptote, that could be an example. All right, with negative 2 x plus 4. All right. So ask yourself, that would be the vertical. Dividing those would give you the horizontal. All right. You can make up any other number combination as long as those two things, all right, still existed. All right. That those two numbers are divided by give you that, and the solution of the factor, the denominator, gives you that. Okay. Now here's one a little bit different. All right. This is getting horizontal right there. That's like at I'm going to go down and fill that in. That's going to be y equals 1. Your vertical one is going right through there. That's x equals negative 4. All right, some of this other stuff, I know because of the horizontal, this is 1 and 1. All right, this is decreasing from negative infinity to negative 4. It's increasing from negative 4 to infinity. See your teacher for more explanation. Okay? All right? It's decreasing to this asymptote, increasing to that one. Okay? Domain. Domain is going to be all real numbers, except x can't equal negative 4. The range. Now, if you notice, both curves are below the asymptote. So that's going to be y is less than 1, because both curves are below. The other example, they had one above, one below. All right, filling out this, we only count these parts for the intercepts. All right. Okay, so my zeros are x equals negative 5. All right, and x equals negative 3. I can do the same thing for this. You can write them as coordinate points if you want. The y-intercept is at 1. Okay? Going on to this. Okay? So now we're doing some rationalizing. So I want to factor. All right? The bottom part's easier to factor first. I'm going to go to menu and equa. Polynomial, degree 2, 1, 0, negative 16. That's going to factor to x plus 4, x minus 4. X minus 4x plus, just to stay consistent. Here we're going to want to factor the cube. So my polynomial changed to degree 3. 0, we did this last chapter. All right. So one of my factors, let me shift menu real quick. Make sure I'm getting a plus bi so you can see both. Okay, all right, so I know that the one part's going to be x minus 4. And what I'm going to do is I'm going to factor this. So that's a box, if you remember. All right. Let me move this over. I got a lot of space that I'm not going to use. Okay, x minus 4. Because I know that that's a factor, that's x cubed. That's negative 64. This has to be x squared. If I divide these two, I would get positive 16. Then I work the box, it's negative 4x squared. The diagonals have to give me what the x squared term is up there. So that's going to cancel out. So that's got to be positive 4x squared, which makes that positive 4x. All right, so that other factor joins this. All right, so what I'm going to do is I'm going to cross off these. And so what I got simplified is x squared plus 4x plus 16 over x plus 4. All right. Going down to the bottom here, All right? I can't factor these because they're not squareds. So what I'm going to do is this one I'm going to take out a negative 1, which makes this y minus 4. So this needs a negative 1. Okay? So what I got is y times negative 1, which is negative y. This is just minus 3. Okay? Nothing can combine here. So I'm just going to write it like this. And that ends up being my answer. Okay? This is a complex fraction. What you're going to want to do with this is I'm going to want to work this individually. So I'm going to start by pretending like this is my only problem. All right? So this side needs a 2x minus 1. Okay? So 2x1 times that would be 2x minus 1 minus 2x over my common denominator. The x's would cancel out, so I'd have negative 1 over 2x minus 1. Okay? So that's the bottom part. The top part, 2x over 2x plus 1 minus 1. Okay? I would want to have a 2x plus 1, so I'm going to multiply by the top and the bottom. Alright? So I'm going to treat that like a negative 1. So that's going to be 2x minus 1 over my common denominator. Those are going to cancel, so I'm going to have negative 1 over 2x plus 1. Now, what happens here is this will be negative 1, 2x plus 1. I'm going to flip this other part, so it's going to be 2x minus 1 over negative 1. So I got 2x minus 1 up top, 2x plus 1 in the bottom. Okay? A negative 1 over a negative 1, that's going to turn into a positive 1, so that's going to go away. That's going to be my answer. Okay? Alright? Moving on to this. Okay? A lot of equa parts. Okay? So what I'm going to do is I'm going to go to menu and equa. Alright, I got 3, I got 17, I got negative 6. Well, whoops, I'm in the wrong. Polynomial degree 2. 3, 17, negative 6. Alright, that's going to be 3x minus 1 and x plus 6. So 3x minus 1, x plus 6. Now, what I want to do on the bottom, this, I want to reverse that to make that negative 1. So when I actually type this in, I'm going to type it in as x squared minus 36. It's a little trick. When that looks backwards, you got to switch that around. We did that in the previous problem. Okay? So that's going to be 1. That's going to be 0. That's going to be negative 36. All right, x minus 6, x plus 6. Now, what the division does is I turn this into multiplication, and these parts are going to change. Okay? Now, when I do that, what I'm going to do is I'm going to do 1, negative 9, and 18. All right? And that's going to now go on the bottom. X minus 6, x minus 3. Okay? Then I'm going to factor this other one, which is 2, negative 1, negative 15. X minus 3 and 5x plus and 2x plus 5. All right? So what happens here is I'm allowed to cross off things alike vertically and diagonally. Okay? So this is alike and this is alike. All right? I'm not allowed to cross these off. All right? I can't cross those off. Whoops, this should be I'm sorry, this one of these should be a plus 6. So actually I can't cross those off. That and that. Okay? So what I got left over up top is I got 3x minus 1, 2x plus 5. I've got a negative 1, an x minus 6, and an x minus 6. Okay? So I can cross off those. Alright, and that's my answer right there. Okay, moving on to 17. 17, they've already factored it for you. I can cross off this and this. So when they get down to restrictions, it's pretty simple. This is the whole, so the solution of that one is negative 6. I can cross off x plus 2 and x plus 2. Solution of that, negative 2. I can cross off x plus 5 and x plus 5. Solution to that, negative 5. Only thing left over, 3x minus 5 and 4x minus 7. So this is like holes. You can think of restrictions like holes. All right? The other thing that restrictions are the vertical asymptotes. So this solution would be 7 over 4. So this is sort of like when we do the domain, okay, all real numbers, except, okay, it's the same concept, all right? All right, moving on. We only got 2 left, so hang with me, all right? So this, I would got a factor, all right? That's pretty easy. You should start to learn what that stuff is, all right? A lot of that should start coming quicker to you, all right? That's x minus 7, x plus 7. So now I'm no longer using this part. All right, so this side is missing an x minus 7. All right, so what I'm going to do for that, all right, this side's missing nothing. All right, so I want to multiply those two. So I'm going to make a box for that. It's a pretty terrible box, hold on. And I'm going to multiply x plus 6 and x minus 7. So that's x squared and 6x. Negative 7x, negative 42, okay? So up top, what I got is I got x squared minus 1x, because that's what these would combine to, minus 42, plus 4, all over my common denominator. Now the only things that are going to combine are those two. So that's going to be x squared minus 1x, minus 38, okay? You can see that there. On the bottom, I'm going to have x minus 7. And x plus 7. Okay? Moving on. Down here, okay, that first one would factor. I think everybody knows that's going to be y plus 1, y minus 1. All right, y minus 1, y plus 1. This is going to be 3 and y minus 1. Okay. All right. Now, what's this side missing? This side just missing a 3. So I multiply by 3 there, 3 there. Okay. All right. This side's missing a y plus 1. All right. So what you got to do is you're going to multiply 3 times y, which is 3y. I got to treat that like a negative 5. So that's negative 5y minus 5 all over my common denominator. Those y's are going to combine to negative 2y, all right? And that's going to be a minus 5 all over 3, okay? So I'd write negative 2, y minus 5. I think what they do is they take out a negative 1 and make that y plus 5. I wouldn't get picky on that, all right? And then the bottom is going to be 3, y plus 1, and y minus 1, okay? So a lot of skills involved, okay? All right? A lot of factoring skills, things of that nature. Use equa, that's going to be important. The big thing that I would say is understanding how you get those asymptotes and holes. So as a reminder, if I had an example like this, just to give you something, as a review, all right, say it's 2x minus 1. All right, the vertical asymptote is going to be the solution of that. So that would be x equals 1/2. Change the factor to the solution. The horizontal asymptote will be these two numbers divided by each other. All right? If you ever cross anything off, okay? If you ever cross anything off, that's considered a hole. This chapter takes a lot of reps and a lot of practice, but you can do well if you just use some of these key concepts.